Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Virgin Orbit. So let's dive right into it. Now, first thing we have to understand, we are talking about a system that provides launch services for small satellite. They're not targeting for big ass satellites or geostationary satellite. They're targeting small ETBT satellites, basically anything below 300 kilograms. So that's the whole point of it. And it was founded on March 2, 2017 as an independent branch. Virgin Orbit was like, think of it this way, it was a subcategory of Virgin, whole system where they have Virgin Galactic and all that jazz. So in around 2017, they're like, no, you will become your own independent system. And what they are trying to sell you is basically a 3-stage system, aka air launched 2-stage rocket. So first stage would be air and then normal 2-stage system. So that's the whole idea with this. So the aircraft is the main interesting point, simply because they originally wanted to use the same aircraft they were building for their Virgin, basically White Knight, but problem was it was too small, and so they started to go to Boeing 747, a big ass plane, the 400 series class. Now the primary reason for choosing this system is like it was kind of pre-built for this sort of use, simply because whenever you're talking about jumbo jets, they need a lot of maintenance, and engines are the primary things for maintenance. But here's the problem, think of it this way, you are an operator, you're operating hundreds of these planes. You will only know one or two airport or one or two engineering airport where like I can bring the engine here and refurbish it. But here's the how the heck you're gonna transport something huge as this? You can't. It's very difficult, or you have to disassemble them a lot to transport it, which is very expensive. So Boeing, they are like, okay, this is a use case. So what if every plane that we are building, basically every Boeing 747, we're gonna give an extra hard point. Hard point is basically where your wing attaches to the basically engine system. So that we're gonna give you one extra hard point. Benefit of that is you can attach whatever you want to attach or there. You can have a payload in case of a rocket or something like that, or you can, why it was intended to used as a engine carrying system. So your 4 engines will be your main system, but let's say a bird strike happened on one engine, that engine is down, you can swap that here, put one fresh here, tada, you're good to go. You can transport it to where it needs to be sent for repair and refurbishment. So that one extra hard point is kind of useful. And this plane is kind of old, simply because it was made, the Cosmic Girl was made in 2001 by Boeing, so it's a 20 years old aircraft. Now be mindful, that's like acceptable for aircraft, and since it's not in commercial service, I'm pretty sure if they had not bought this system, they would have, like, I'm pretty sure retired it to basically freight air traffic system sooner or later, because like in commercial airlines, you're not supposed to use your plane for very long, like it keeps getting demoted. So it does allow for payload. The benefit of that, once they start to utilize this big ass, they can upgrade to 300 kilogram. Their original estimate was around 100 kilogram to 150. 200 was like, very good, but 300 there is achievable with this puppy. Now be mindful, sun synchronous orbit, there are many satellites on sun synchronous orbit, like satellite that I personally download data from, that is NOAA 19, but those are big satellites, they are like around more than a ton. So 300 kilogram, while it's very good for modern system, still not like NOAA level satellite kind of good. Then let's understand the rocket here, the launch and rocket. Now this is a 2-stage rocket launch system, nothing fancy about it. However, the one unique part about this is liquid propellant. You do not want to have liquid when you are talking about something, a moving platform. So it has a rocket propellant one, aka kerosene, and liquid oxygen. Now biggest issue with this system is if you directly fire it and you ignite the engine, it's gonna go boom. Why? Simply because the fluid will be, the fluid direction will be this, engine will be trying to drain the system in this direction. There will be guaranteed void that will go into your turbo pump, and turbo pump will go boom, then your rocket engine goes boom after that. So fundamentally you need what we call pusher systems. So they are calling their rocket engines Newton. They have like Newton 1, Newton 2, Newton 3. So Newton 3 they are using, and this puppy have supposed to fire for 180 seconds in the first stage configuration, and Newton 4 which is supposed to fire for 360 seconds. So second stage actually fires for much longer than that. And the small booster for propellant stability, and this is a very critical aspect. If you ever notice Saturn 5 third stage staging operation, you will notice that stages, okay, engine is off, but you will still notice 4 kind of flame coming out of there. Those are what we call small boosters that are solely there just to push the rocket in one direction, so propellant goes in another direction, and then engine can drain it properly. Once the engine is online, engine is like, I got this. But in free floating environment, you never want to start your liquid propellant engine, it will go boom if you do that. So that's why they have a small system. Now be mindful, you will rarely see that in live stream, because that's a very small charge. It's not like whoosh, it's not like solid booster of a space shuttle. So it's like you have to look very carefully. Oh, now they did that. It's almost like a green flash how Falcon 9 used to have. I mean, like, they still have it, but it's like very small now. So that's the, and total system weight is around 30 ton. So it's a big stuff. So are there steps? Now, first step is the only interesting part, that is the air launch. That happens at 11 kilometers. Now, around 32,000 feet. They can do like a bit more and a bit less, but that's the whole point of it. Now, the moment the first boosters fire, they stabilization, and then it tries to do vertical climb as quickly as possible. And consequence of that, you are still dropped from a plane. You are still traveling at very high speed. Now, of course, subsonic speed, but you are still traveling. So, consequence of that, that rocket engine fires. Everything is good, but the moment it tries to do, it starts to fight against atmospheric drag. Like it was not going directly like this, it was like this and then going this, so it starts to vibrate a lot, and you can see that in live stream where it's like it's whoa, 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 whoa. It's like, okay, stabilize. Now this has happened in many times, so it's like kind of known behavior and they know how to compensate for that, so it does work. So small boosters fire, then normal rocket operation. Once it's stabilized, once it's like this, everything is normal, everything is like garden variety rocket. However, because it's fired at such a high altitude, it does have the benefit, the max Q happens almost instantaneously, simply because while you are accelerating, you are nowhere is the speed of a Falcon 9 or any other normal rocket. But normal rocket, by the time it's crossing 10 kilometers, traveling much faster. So it does have a have to fight the atmosphere, because most of the atmosphere is below 10 kilometer, and majority of it is in 1 kilometer slice. So reality is, once you are at that high kind of height, you will pick up speed, but you will take time to pick up speed. By the time you have taken picked up the speed, your height would be so high that atmospheric drag would be like nope. So it's kind of cheating its way. Now max U a mathematical status, so it always applies, but in this case they will call out max U the moment the rocket is launched. Like the moment it does the vibration thing, then it launches, like max U over, done, go home. Benefit, your payload fairing can be much lighter. And because it's not fighting against the atmosphere, it can achieve ludicrously high G forces. I'm talking 5G of continuous acceleration. That's amazingly fast. And quick vertical climb. After that, it's like normal rocket operation. So what we can expect in the future? One thing you have to understand, at this point in time, I'm kind of surprised there how many people are developing, and I'm talking about including ISRO also. It's like every Tom, Dick and Harry is like, Da shall build a small satellite launch vehicle. It's like there is like at least 20-30 at this point in time that are active. So reality is the market is getting a bit too crowded, and for first, like you can't have 10-20 operating system, you can only have 3. So reality applies like that on almost everything. You cannot have hundreds of suppliers for something. So, and their launch operation cost is around $12 million, which is very high given the fact that price is almost the same price what Falcon 1 used to have. So it's like, why would anybody choose you? Right now they have the first mover advantage. Yes, there are many people trying to develop the system, only Electron rocket is complete, and if you do not want to go to their launch site, or they are busy, like, because again, while they do want to launch as many as possible, they still have like, okay, we have to build the system, we have to test it, then launch it. That takes time, the throughput is low. So in that throughput, let's say you are like, no, I want to launch my satellite next week, can Electron rocket do that? No. So this will like right now. So right now this company is getting a lot of orders, and I'm reasonably sure for next 1 to 2 years they will have more than enough. However, I do not see them going past that. Like again, they will last a bit longer than, but I do not expect them to last way too much, simply because there's support vehicles. There are other rocket companies that are like, give me only this, remove the plane, give me only this, and I will give you a rocket launch that happens from anywhere, simply because Astra rocket system, they specifically designed the system so it's completely containerized. The reason for that, so it can be carried utilizing Air Force heavy aircraft system, C series aircraft, and they're like, okay, 3 containers sent inside a aircraft, transport it wherever you need to, then launch from there. So compare that to this puppy. You have to understand this. It's like there is not very what we call unique selling point. It's like you have unique selling point that you can send around 300 kilograms. There are bigger rockets that can send much bigger than that, and there are cheaper rockets that can send much less than that, and like almost similar to this, like around 200 kilograms from Electron rocket. So it's like, what do you actually provide? Like, of course, right now there is like far more demand than supply, but once supply catches up, then the market forces will shift. So I do not see them very long-term success. I can almost feel like they are doing what the same thing Samsung did when they started to jump into what we call photography interchangeable lens camera market. They jumped into, it's like, yeah, mobile division far more profitable. Yoink, they went out of it. So I kind of see that kind of system here, because yes, it will work for 1 to 2 years without any issue, but what happens if 15-16 companies starts to reach into this market, and many of them starting prices are lower than this? So let's see what happens. So this was my presentation on Virgin Orbit. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me a disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.